Hello friends, today's question: a thin rod of negligible mass and area of cross section 4 into 10 to the minus 6 meters square suspended vertically from one end has a length of 0.5 meter at 100 degrees centigrade. The rod is cooled to 0 degrees centigrade but prevented from contracting by attaching a mass to the lower end. Find this mass. And B, the energy stored in the rod given that a rod's Young's modulus and coefficient of linear expansion G are given to us. In this case, we are given that the rod is suspended vertically. So this is the rod, and initially it is at 100 degrees centigrade. And when it is cooled to 0 degrees centigrade, this rod is supposed to contract. But a mass is hung from this rod, which is given as M. Suppose because of this mass, the contraction of this rod is prevented. Okay. So we are supposed to find out what will be the value of this mass and energy stored in the rod. So we try to understand that when the temperature is lowered, this rod should be contracting, and this contraction is nothing but a thermal strain, and this thermal strain is prevented because of this mass that is connected with this rod. Okay, so we can say, thermal strain prevented due to contraction. Thermal strain is due to when rod is cooled from 100 degrees centigrade to 0 degrees centigrade. Now because of this cooling, the rod attempts to contract. But the contraction is prevented by the mass which is connected to the lower end. But contraction is prevented by attaching mass M at its lower end. So basically we can say that the contraction is being balanced by the mass, or thermal strain is being balanced by this mass. Okay, so let us first of all find out thermal strain. Thermal strain V is given as alpha multiplied by our change in temperature. Alpha is given to us as coefficient of linear expansion is 10 to the minus 5, and difference in temperature is our 100 degrees centigrade. So we can say our thermal strain will be equal to 10 to the power minus 3. So obviously the mass will be, you can say, generating a kind of force, so which is going to prevent the contraction. So we say that the force required to prevent contraction. Force required to prevent contraction. And you can say force will be equal to strain multiplied by area. Force is equal to strain multiplied by area of cross section, and we already know that our stress is equal to y multiplied by our strain. And Young's modulus is given to us. Young's modulus is our 10 to the power 11. So this becomes 10 to the 11, and we are given that the strain is a thermal strain. I forgot to mention this is thermal strain. Thermal strain we just calculated is 10 to the power minus 3. So this comes as 10 to the power 8. So therefore, our force will be equal to, and cross-sectional area is given as 4 into 10 to the power minus 6 multiplied by 10 to the power 8. Sorry, this is stress, not strain, my mistake. And the force, that is F, is now equal to our 400 Newton. So we were able to find out the force. So therefore, from this force we can find out easily our mass. So we can say that the mass required to exert the force of 400 Newton mass required to exert a force of 400 Newton, you can write that our M F upon G, this is our 400, G we are supposed to take in 10, so this becomes 40 kg. So we solve the first one, that the mass required is our 40 kg. In the second part, the energy is stored in the rod. So the energy will be stored in the rod in the form of the elastic potential energy, and this formula is given as half into stress into strain multiplied by volume. Energy stored in the rod so elastic potential energy stored in the rod, elastic potential energy stored in the rod will be equal to U half stress strain multiplied by volume. And volume we can calculate. Volume will be equal to area of cross section multiplied by length of the rod. Volume is equal to area of cross section multiplied by length of rod. Area of cross section is given as 4 into 10 to the power minus 6, and area of cross section is given as area of cross section is given as 4 into 10 to the power minus 6, and length is given as 0.5. So this becomes equal to as 2 into 10 to the power minus 6 meter cube. The rest of the values we already know. So we can say energy is equal to half into 10 to the power 8 multiplied by 10 to the power minus 3 multiplied by 2 into 10 to the power minus 6, and linear coefficient is 2 and 2 goes away, and this comes as 9 and this is 8, so this comes as 10 to the power minus 1 joules, or we can say U is equal to 0.1 joule. So this is the energy stored in the rod. Okay. This completes the question. Thank you.